6.1, we're going to be looking at roots and radical expressions. Let's go ahead and see the n is called our index, and the a is called our radicand. All right, let's go over some common powers that would probably be a good idea for you guys to kind of memorize and know. So 1 squared would be 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 7 squared is 49, 8 squared is 64, 9 squared would be 81, 10 squared is 100. We have 121. For 12 squared, we have 144. For 13 squared, we have 169. For 14 squared, it is 196. For 15 squared, it is 225. 400, and finally for 25 squared it is 625. Next we'll go ahead and look at some common cubed roots. Okay, and here's some other common powers that you might see. 1 to the third is going to give us 1, 2 to the third would give us 8, 3 to the third would give us 27, 4 to the third, that'd be 4 times 4 times 4, would give us 64. 5 to the third would be 125. 6 to the third is going to be 216. 343. And 10 to the third would be 1,000. Let's look at some powers of 4. 1 to the fourth would be 1. 2 to the fourth, that's 2 times 2 times 2 times 2, would be 16. 3 to the fourth is 81. 4 to the fourth is 256. And 5 to the fourth is going to be 625. And just a few more. 1 to the fifth is 1, 2 to the fifth is 32, and 3 to the fifth is 243. Alright, we have the square root of 216, and I want to simplify this. There's a couple of different ways I can look at it. I got to find some squares that I can pull outside of the square root sign to kind of break it out of there. So a simple way of doing that is coming over here and kind of thinking about the factors of 216. So, and I always start with 2, when we'll use 2 until we can't anymore. So 2 times 108 would give me 16. 2 times 54 would give me 108. 2 times 27. Kind of done with the 2s, so now I'm going to move on to the 3s. 3 times 9, and then 3 times 3. And what my goal is here is I'm working with square roots because that's what that means. And I'm going to circle pairs of 2s. So I have 2 2s and a pair of 3s. So that's going to look something like this. It's going to be 2 times 3, and then I'm left with a 2 and a 3 inside. So the simplified version of this becomes 6 root 6. All right, let's take a look at these three. Let's see how we can simplify them. So this one's pretty simple. We know that the square root of 16 is 4. So we can take out the 4. Now we got to figure out, what about the 8? What can I take out of the 8s? You can work that kind of the same way. I'll show you two different ways to do it. You can either list out your 8s so that you can see, and again, working with a square, I would just circle groups of 2, so that would leave me x to the 4th. Another way I could look at that is I could say x to the 8th times 1/2, and that would still give me x to the 4th. So either way you look at that is fine. Once you get really good at them, then you'll probably be able to see it without drawing out all your x's. All right, let's look at b. b is to the cubed root, so I'm going to simplify this. I'm going to start with my a's, and I have 6 of them. So I'll list out my a's, and I'll group them in 3s, and then I'm going to list out my b's, and there's 9 of those, and I will also group them in 3s. So this simplifies down to I have 2 sets of a's, so that simplifies down to a squared, and I have 3 sets of 3b's, so that simplifies down to b to the 3rd. Now let's go ahead and look at c. I have 8 x's. I need them to be in groups of 4. So I have x to the 2nd. Now let's look at y to the 12th, the other way I showed you, and that would be by 1/4. So that would be y to the 3rd. So my simplified version would be x squared y to the 3rd. Something else I need to point out here. This 4th power over here, and the fact that there's not a negative sign in front of our cubed root, tells me that I have to have a positive answers, because remember, when you're working with square roots, you can have a positive or negative answer, both of them. So we have to make sure we keep this in the positive side. So for y to the 3rd, I need to put the absolute value sign around that to show that it's going to stay positive no matter what. And if that doesn't make sense, let's look a little further as to why we have to do that. If I have negative x times negative x, I'm going to generate a positive x. But if I have negative y times negative y times negative y, these two will turn positive, but it will turn back into a negative, and that's why I have to use the absolute value. Go ahead and give D, E, and F a try, and we'll come back together and look at the answers. Okay, let's take a look. For D, we were looking for the square root of 81, and that's 9 times 9, and x squared. For E, you can see that it's just to the 1/3. So I have A to the 4th and B to the 5th. Now I know this is negative, but we don't put an absolute around that because our index is negative. We only use absolute when our index is positive, like in F. So we have x to the third, y to the fourth, and we want to make sure that this x to the third stays positive, so that's why we put the absolute value around that one. All right, I'm going to take a look at G. I have negative 125 a to the third, and I want it to, and it's to the third, it's to the cube root, sorry. So how would I go about simplifying this? Well, what times itself 3 times gives me 125. Negative 5, and a to the third, that would just be a. .125, so what times itself gives us that? It would be 0.5. What about the cubed root of 8 over 216? Well, let's start with the 8. What times itself 3 times gives us 8? 2, and then 216. You can look back at our sheet of our most common roots, and we see that 6 times itself 3 times gives us 216, and we can take this down further, so it would be, the most simplified version would be 1/3. J, what times itself gives us 121, or negative 121? Take a look at J. Basically what this is saying is that negative 11 times negative 11 should give me negative 121. But a negative times a negative would give me a positive 121. So this is not a real root. Okay, and the last example is the square root of x plus 5 squared, and that simply just becomes x plus 5.